always do well in the classroom. They are achieving really, really high, and I am just so proud of them. So I'm going to say good evening to Sam. Sam, say good evening.
Evening.
Good evening, Sam. And I'm going to say good evening to Zelig.
Good evening.
And Sam and Zelig, how are you feeling this afternoon? Sam, we'll start with you. How are you feeling?
So I'm feeling really excited about this radio show. It's my first time.
Oh my gosh.
And it's just really blown my mind how it's my first time on the radio.
Do you know what, Sam? What you just said is absolutely amazing. And you are just so confident. And some of the words that you use and the phrases that you use, they are not for year 3. They are for older children. And I'm really pleased you said that. Zelig, how are you feeling this afternoon?
I'm feeling very, very, very excited, and it's my second time here.
Yep.
And I'm happy that I'm here with my friends.
That's fantastic. So, Sam, tell me, why do you think I invited you into the studio today?
Well, on my PTRS, which was the number David's just been talking about, I'm first in my year. I really like math, and I know a few methods of calculation.
Right. Now, do you think you're better than me?
Yes.
Oh my, say that again. Do you think you're better than me?
Yes.
Wow, today's show is going to be brilliant, because if you think you're better than me, I've got a lot to worry about. I'm pleased you said that. Zelig, do you think you're better than me, or do you know you're better than me? What do you think? Do you think or do you know?
I know.
You know you're better than me. How do you know you're better than me?
Because I know a lot of methods, and you're teaching me lots of stuff.
So hang on. If you know you're better than me, but I'm teaching you how to be better than me, who's better than who?
You're better than me at the moment.
At the moment.
But when I'm 12 or something like that,
yeah.
I'll be better.
Do you know what, Zelig, that's interesting, because I know when you are 12, I know you are going to be competing against me. And I think it's going to be before 12, to be honest, Zelig. I think you and Sam, before you're 12, you're going to be competing not just with me, but other mathematicians who are way older than you. Way older. So Sam, in your classroom today, what topic were you doing in maths and numeracy?
So what we were doing was time. So we were trying to tell the time of AM and PM. We were doing digital clocks and a usual clock.
Wow.
And we were also showing the time. We were converting the digital clock into analog clock.
Hang on.
You know what analog is?
Exactly. Tell me, please.
It's on the clock that has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and it's round and all of that.
Oh, okay. So analog clock is the one that's got the numbers 1 to 12. So digital, what does that look like? Can you describe what that looks like, the digital one?
So digital is basically just like a box or whatever the shape is, and it says the time, like if it's 4:35.
Yeah.
Instead of showing it with arrows like the analog clock, it'll just show normal numbers, and the digital clock is easier to read than the analog clock.
Okay, so you find digital easier to read than analog. And what about those clocks that have got Roman numerals?
My dad taught me Roman numerals. So 1 is 1 line, 2 is 2 lines, 3 is 3 lines, 4 is a V and then a 1.
Hang on. So V and then the 1, or is it a 1 and is it the 1 and then the V? Because the V is what? Yeah, 1 and V.
1 and then the V. 5 is V.
Yep.
6 is V and then the 1.
Yeah.
7 is V and then 2.
Yeah.
2 lines.
Yeah.
8 is V 3 lines.
Yeah.
9 is 1 and then X.
Right.
And then
Hang on. Where did the X come from?
X is 10.
Oh, I see. So why is the 1 before the X then, and not after?
Because so X is 10.
Yeah.
So that if 10 and there's 1, so if 10 minus 1 equals 9.
Oh, okay.
X is 10. X1 is 11, and then x and then 2 lines is 12.
Oh, I see. So if the 1 comes before the v or the x, you subtract. If it comes after, you add.
Yeah.
Wow, Roman numerals. So did you know about that as well, Sam?
Yes, because once in school we saw Roman numerals work and we have to work out what time it was.
Wow. And Sam, can I ask you again? You know when you're at home, when you're at home with your mum and dad, how much maths do you do? Do you do maths every evening, or do you do it when you have your homework, or does mum and dad, do they sort of use maths in everything with cooking, getting up in the morning, bedtime, and that sort of thing?
So I sometimes do math on my homework, but I find that a bit easy. So I do play TTRS a bit at home, and it makes me quicker on my timetable.
Wow. Do you know what? We've just got into the show, but I could be here all day talking with you two because you're so full of enthusiasm and excitement for maths, and that for me is absolutely amazing. Right. Okay. I've got some words in mathematics that a lot of older people do not understand. So I'm going to throw a couple of these words out to you. I'll start with you, Zelig, okay? Can you explain to me your understanding of these words, okay? If you want to use your arms to show me, or if you want to write on the whiteboard, you can do that as well if you want, okay? But have you heard of the word parallel?
Yeah.
What is?
So parallel is when there is 2 straight lines.
Yeah.
The parallel lines never meet.
Oh.
And they have the same distance to each other. So like if I do this and this is not parallel. But if I do this, that is parallel.
So Zelig, what makes that parallel?
Because there's 2 straight lines and they don't meet.
Oh, okay. So parallel lines never meet. Right. Okay. And so the word perpendicular. Do you know what that means, Sam?
Yeah. So perpendicular is like usually something that holds right angles. So perpendicular, like it looks like an L. So like that could be perpendicular, but perpendicular wouldn't be like it wouldn't be like this because that's going forward, which makes it acute.
Okay. So perpendicular is where you've got your vertical line and you've got your horizontal line, and then they meet at the corner. Is that correct? And then at that corner, there's a right angle.
Yes.
What do you know about a right angle?
So right angles are basically stuff that you can find like maybe on a square.
Yeah.
You would find it like here and here and like you'd find 4 right angles on a square.
Right, and how big, using degrees to describe, how big is a right angle? How many degrees big is a right angle?
A right angle would be 180.
Right, what's half of 180?
90.
So a right angle is how big?
90.
Well done. So if you've got 4 right angles in that square, what is the total number of degrees you've got in that square then? Are you going to do column method? Okay, brilliant. I like what you're doing.
390 degrees.
8 plus 8? Just check the 10. 8 plus 8?
360 degrees.
Perfect, well done, fantastic. And Zelig, as Sam was answering, you drew a circle, yeah? So Zelig, you put a line down the middle of your circle, yeah? When you put that line down the middle of the circle, what did you divide your circle up into? When you drew that one vertical line, what did you do to that circle? You divided it into how many?
2.
Right, and what do you call each of those 2 parts? What's the correct semicircle? Good. And how many degrees are there in a semicircle?
3. 180.
And how many degrees in a right angle?
90.
And how many degrees in a full circle? Fantastic. Right. Okay, listeners, you can see today's lesson is about me showing off the incredible confidence and knowledge of these two young year 3 pupils, okay? Yes, I do know them. And the reason why I invited them onto the show is because they are a reflection of what is going on in our classrooms day by day. They are obviously being well supported at home by their parents and families, but then when they go into the classroom, they must be taught by some very, very good class teachers. And every time when we listen to the news, we hear about teachers not doing this and not doing that. But look at these two boys. Look at the talent that they have got. And that has come from the classroom, their teachers. It's come from the intelligence that they were born with. And it's come from a combination of home background as well. The support that they are getting from their parents and families at home. And for me, that's absolutely amazing. Right, now, when I spoke to Sam over the weekend, Sam gave me a challenge. And he said to me that he can answer 10 multiplication questions within less than a minute. Now, to be able to do that, that is way, way faster than expectations for the MTC next year in 2026, which is what they were doing. Sam then said to me that in his classroom, his sound check, what was your last sound check, Sam?
My last sound check, well, my best sound check was like total sound check, so the best you can possibly get. Mm-hmm. But my last sound check was something like, I don't know.
Was it less than 1? Was it less than a second?
So each question was about under 3 to 4 seconds.
Wow, that's very fast. So just in case you don't know, with the TTR Rockstar, which stands for Times Tables Rockstars, and the TTRS, it came about because we wanted to encourage our children to want to learn their multiplication tables. Now, for me, it's not just about knowing their times tables, it's about using the multiplication tables, and it's about applying the multiplication tables. Because yes, Sam and Zelly can answer 3 times 4, 6 times 7, but can they use that in a calculation? Can they recognize that in a calculation? And the answer is yes. So Sam, I'm going to start with you. So do you want to write the answer or do you want to tell me the answer? Why don't you just tell me the answer?
Okay.
It'll be quicker, yeah? All right, so you're going to do this for mental calculations, yeah? And then Zelig, I'm going to come to you after, okay? So, Sam, are you ready?
Yeah.
7 times 9.
7 times 9 is 64.
Try being very close. 7 times 9.
63.
63. 6 times 12.
72.
8 times 7.
56.
6 times 4.
24.
3 times 8.
24.
2 times 12.
24.
What do you notice about those last 3 questions?
They're all 24.
They're all, the answer is 24. And one more, 12 times 8.
12 times 8 is 96.
How much?
96.
96, fantastic. Now listen, Sam has not seen the questions, but you've seen the way that Sam answered those questions really quickly and really confidently. And this is exactly what we want. Now, I'm working in another school at the moment with some teachers, and what we've done is that we've started the children in year 3, and these 2 boys are in year 3. And what we've realized is that if we start getting them ready in the last half term of the academic year, which is now, then it has a knock-on effect for when they actually start year 4 in September. Sam is an example of high expectations. There was no hesitation. Yes, of course, he might have got one a little bit wrong, but that's normal because he corrected himself. And that to me is the most important part. He said an answer that was not correct. He didn't panic. He gave me a correct answer within a second later. That is real learning. And that's what makes me really excited about working with these 2 young, amazing boys. Right, Zelly, are you ready?
Yeah.
Bit closer for me. Right, 9 times 7.
63.
3 times 7.
21.
9 times 3.
27.
8 times 4.
32.
7 times 7.
49.
Right. Now, Zelig, I've got 3 extension questions, okay? Now, these are not part of the times table, but I want to prove something on the radio. No, you're going to do this for mental. You're using your brain, yeah? Now, I've chosen these questions because I'll tell you after where these 3 questions came from. Because if I tell you before, you might panic a little bit, okay? So I'm going to give you 3 questions. Now, Sam, if Zelig is not too sure, you can always jump in because you're working together, okay? But I'm doing this because I want to see the way that you are mentally, don't look at my question, I want to see the way that you are mentally. This young boy, Zelig, I'll tell you something now, because I know there's a lot of head teachers watching, okay? Zelig is very, very clever, but what I like about Zelig, okay, is that Zelig and Sam, they are examples of 2 young, excited, intelligent boys. Of course, Zelig is going to want to know what the questions are. That's what young children do. And for me, that is never a problem. So I put my hand over the questions, and Zelig knew what we're here done, and we're laughing about it. Zelig, question 1, the first one. 2 times 14. 3 times 25.
75.
Well done. 4 times 13.
52.
Wow. Sam, can I give you a couple of extension questions, yeah? Right, 4 times 30. Do it in your head. You can do it in your head. 4 times 30.
120.
Get a bit closer because I can't hear you.
120.
Fantastic. 2 times 55.
110.
3 times 75. Now this last one, it is challenging. If you want to write on the board, you can do. But if you want to give me the answer, you can. So 3 times 75.
I know.
3 times 75. So 75 plus 75. Write it down for me, Zelig. Don't let Sam see, because I want Sam to have a go at doing it.
225.
Wow, what did you write down, Zelig?
225.
That is amazing. Now, the average adult would not be able to answer that question as quickly as you both did. But once again, that shows your intelligence, and that's what this show is all about. Now, listeners, I've already had a couple of head teachers. Right, one of them has said, "Where did these 2 boys come from?" Not literally, where did you come from? But it's like this. They're asking me, where your parents? How did they create you? That's what they're asking, because they cannot believe, because they're watching you live, and they cannot believe the confidence. And one of them has said, the way that you showed the whiteboard to the screen without me prompting you, they said that is absolutely amazing. And Sam, the other head teacher, has said to me that it's your confidence that she's looking at. It's your confidence, it's the way that you're speaking. So Sam and Zelig, you're making me feel really, really good this afternoon. Okay, polygon. What is a polygon?
So a polygon.
Okay, so get closer to me, Zelig. Polygon.
So a polygon is a shape that has more than 3 sides or more, and it's always closed, like triangles, squares, and trapezoids or trapeziums.
Right, Zelig,
all of that, every single shape that's over 3 corners and sides or vertices is a polygon.
Right, Zelig, you mentioned the word closed. Why did you use the word closed? What do you mean by that? The shape that is closed.
So this isn't a shape that's closed. This shape isn't a shape that's closed, but so you start it and you put it back to the starting line.
Right.
Like
so
a circle.
Okay. So are you? So do you mean? So do you mean that the vertices must all be connected?
Yeah.
What's another name for a vertice?
Corner.
Well done. Well done. Sam, so we know what a polygon is, don't we? Sam, can you tell me how many sides are there on a pentagon?
On a pentagon there are 5 sides.
Zelig, how many sides on a hexagon?
6.
What do you call a 7-sided shape?
Heptagon.
Wow. What do you call a shape that's got 8 sides? Sam?
Octagon.
Zelig, what do you call a shape that has got 9 sides?
None of them.
What do you call a shape that's got 10 sides, Zelig?
Decagon.
And Sam, do you know what you call a shape that's got 12 sides? You can answer, or you can. Do you want to let Zelig answer?
Yeah.
Right, Zelig?
A dodecagon.
A dodecagon. Do you remember? So a dodecagon, yeah? Now you won't forget that, Sam, because someone's answered that. But let me show you off even more. The other day we were talking, Sam. Can you tell me how many years are there in a decade?
10.
How many years in a century?
100.
How many years in a millennium?
1,000.
How many years are there in a bicentenary?
A million.
Okay, I know what you're doing, and that shows how clever you are. Right, in mathematics, how many years are there in a century?
100.
Right, so a centenary comes from the word century, which means 100. And in maths, if I said bicycle, how many wheels are there on a bicycle?
2.
Right, so if I say bicentenary, what do you think that means?
A 2-sided shape.
How many years are there in a bicentenary?
200 years.
Good boy. That's what I wanted to hear from you. Well done. So what I'm doing, I'm constantly pushing and challenging you. Now, my next question, I don't think you're going to get correct. Now, Zelig, are you going to challenge me? Sam, you're going to challenge me. Okay. By the way, listeners, both of the 2 boys in front of me said to me this afternoon that I'm sitting in this chair interviewing them, but they want to turn the tables. They want to be in this chair interviewing me. Can you imagine that? Can you imagine? That would be such an amazing radio show being shown live on live stream. That's going to be brilliant. Write this question down for me. Get your pen ready. Write this question down. 9 plus 3 multiplied by 12, multiplied by 6. 9 plus 3 times 6.
2.
Careful, times that by 6.
Oh, times.
Yeah, so write the whole question, Sam. Sam, write 9 plus 3 times 6.
Put the answer.
So put times 6, yeah?
Can I say?
Right, hang on. Right, so Sam, do you want to have a go at answering it? Zelig, can you tell me, write the question down for me again. So it's 9 plus 3 times 6. Right, Zelig, let me tell you what my answer is, and can you tell me if I am right or wrong? So I think the answer is 9 plus 3 is 12, and 12 times 6 is 72.
Wrong.
I'm wrong. Why am I wrong?
Because you have to do the time, like there's 2 symbols in the question. You have to do the times first, then the addition. So, and the answer is 27 because 3 times 6 equals 18.
Yeah.
18 plus 9 equals 27.
Wow. And Zeli, can you tell me, you said that you have to do the multiplication first. What rule have you been taught that's telling you to do that? How do you know to do the multiplication first?
Because multiplication is stronger.
Right. Have you heard of BIDMAS?
Yes.
What does BIDMAS stand for? What do those letters, because those letters are an acronym for some words here. B stands for brackets. The I stands for indices, square numbers. What does the D stand for? D.
Divide.
Right. What does the M stand for?
Multiplication.
The A stands for?
Addition.
And the S stands for?
Subtraction.
So is that the reason why you did the multiplication before the addition? Because you were following BIDMAS? Yeah? Sam, do you understand that?
Yes.
So whenever you've got a calculation that has got more than one different operation, around the whole world, we have to use BIDMAS. Yeah?
Okay. Like how I was showing you on the weekend, can I show you how to do bus stop?
Right, you're going to show me, we're going to have the bus stop, okay, after the break here. And Sam, that is something that I want you to show me. And then you're going to show the people watching online as well, because they're going to be very interested. But Sam, when you use bus stop, what are you doing? What operation? What do you use bus stop for?
Bus stop is a It's a method for division.
Short or long division?
You can do. I think it's short.
It is short, okay? Right, so short division is when we are dividing a number by a single digit, and long division is when we're dividing a number
by a 2-digit or over.
Fantastic. Well said, Zelig. Well said. Right, listeners, some of you are sending me hearts, and you're sending me fingers and everything. My last one is, because I know that Dean has already sent out the information. I'm getting that online. The last one is, I'm not happy about this last comment, because this teacher has said, Mr. Numbervator, get out of your chair and put the Sam and Zelig in it. That is, I'm not happy about that at all. That's come from a head teacher, okay? Mr. Numbervator, get out of your chair and put Sam and Zelig in place of you. I know why they said that. It's because, boys, you are just doing so well. We're going to go for a really, really short ad break. And then when we come back, Sam is going to teach me about the bus stop method for short division. Zelig is going to talk to me about square numbers and cube numbers, and then we're going to finish up with money, where you're going to show me what you know about money, about the money that we use at the moment, yeah? So there's a lot to get through. Are you enjoying yourselves?
Yes.
Right, let me start with you, Zelig, this time. Zelig, what are you enjoying about today's show?
I'm enjoying that we're actually on a radio and that you're showing myself.
Zelig, do you know what? There's a lot of listeners. There's a lot of people listening and watching. I mean, Dean will be able to tell us how many are watching, but Zelig, there's a lot of people listening to you, and that's the reason why I'm getting a lot of messages, a lot of balloons. You know, when they show a balloon, it means that, you know, they're happy with you, aren't they? And then Zelig, I'm going to make sure there's time so you can tell us about how you are looking at investment and doing your Bitcoin. Yes,
Bitcoin and trading.
Exactly. That's what I want to get onto the show as well. Okay? Yeah. So, what are you going to do now when you leave your set? Where are you going to go when you leave your chairs? What's outside the door waiting for you?
Sweets.
Wow. Sweets and what else?
Sweets.
And what else?
Juice.
And juice. Okay. Right now, listen. I don't want to get in trouble with your parents and families here, but I know that because it's a special occasion, I know that they're not going to tell me off, because I did say to them beforehand, okay? I'm doing it because I'm really proud of you. It's not every time you come to the studio that you're going to get all of these sweets, but today I'm doing it because I'm just so super proud of you, okay? So I'm going to see you after the short ad break, and we're going to have a lot more fun. So, see you later.
Hey, Londoners! Are you ready to start your next educational adventure?
Yeah, go. You haven't got a lot of time. Go. We'll do that as well then. Okay, good. Off you go.
And endless possibilities.
D,
Over 200 courses to choose from. There's something here for everyone.
T.
When you want to get your hands
Aren't they brilliant?
workshops,
Aren't they brilliant?
perform on stage
Oh my gosh. I could be here all day with them.
Comics.co.uk and get your latest issue of Mr. Numbervator's Maths Comic Book
Dean, can you
series
put Sam
today.
onto the chair so he's safe? This is stuff and slide off.
Sit up.
Zelly, have a seat.
You with me? Sit back. You are now tuned into the Mr. Numbervator show every Wednesday from 5:30 to 6:30 p.m. on Chalk Hill Community Radio Station.
Oh my
Let's get mathematical.
Well, I'm going to start. I'm going to start the second part of the show by reading a message out to the two boys, because the two boys know who this person is. Okay, and this person has said, tell the two boys their mums are very, very proud of them. It's your mums. It's your mum and your mum. Okay? And that's the message that they just sent me. Look, that's the message that they just sent me. Tell the boys that their mums are so proud. Mums, can I just say, you're proud of them, but I think, I don't think you understand how I'm feeling on the inside to be working with your two boys, okay? Because you know me, but you also know that when it comes to young children, especially young children who are very able and very gifted in maths, that just makes me so excited, because I know that in life, Sam and Zelig, they will not fail. It's going to be impossible. Their life has been mapped out for them already now because of where they are at the moment. And Sam did say to me, or Zelig said to me, that when they are 12 years old, they are going to be way ahead of me. And that is exactly what I wanted to hear. Welcome back, boys. Did you have a nice break? Sam, did you have a nice break?
Yes.
You have a nice break? Zelig, did you have a nice break?
Sure.
Right. Now, Zelig, before we went to the break, you asked me something because you wanted to show off something that you know with the number 37. Is that correct? Right, okay. Right, so but both of you write 37 down. How many times? About 5. That's it. Right. So listeners, just while they're writing this number 37 down, I showed them a number investigation recently. And when they saw the answers, their eyes just lit up. It was absolutely amazing. And for a young person to volunteer and to request, can I show you something? That just shows their confidence and it shows their enthusiasm. Okay, right, so Zelig, start us off, please. So what have you got written on your board?
37 times 3 equals 111. And so 37 times 6, you just have to add the 111 plus, so that makes 222.
Yep.
And 37 times 9 equals 333. And then 37 times 12 equals 444.
Okay, now that will do. I'm going to ask Sam. Sam, take over. So after 37 times 12.
And then, if you like. But then, if you add 1 plus 1 plus 1, that equals 3.
Oh, wow.
2 plus 3 plus 2, that equals 6.
Yep.
3 plus 3 plus 3 equals 9.
Yep.
And 4 plus 4 plus 4 equals 12.
Wow. So that problem, it actually goes a lot further than even what you said, Zelig. Now, people always say, and I was talking to Zelig's dad and to Sam's dad, they always say it's never good to work with children and animals because they're so unpredictable. But I'm telling you something now that for me is the best thing, because when Sam was writing down his answers, you could hear him tapping the whiteboard. And for me, that is all part of learning. That just shows you the excitement that this young 8-year-old has got when it comes to maths. And I think because it's on the radio, the fact that Sam was tapping the whiteboard, that's an incredibly powerful sign of what they like to do. So Zelig, thank you very much for offering to show me. But Zelig, I'm a bit lost. I need some help from you. I'm not too sure what a square number is. Can you help me?
So square numbers are basically like 1 plus 1 equals 2. No, 2.
Two.
1 times 2. 1 times 1 equals 1. 2 times 2 equals 4. 4 times 4 equals and so on. And
What does 4 times 4 equal?
16.
Yeah, because you said 4 times 4 is so on. So
And
4
so
times
on.
4, okay, you go
So
on.
3 times 2 equals 9. Then 5 times 5.
Right, so explain to me, so
So-
what are you doing? So when you say 3 times 3, what are you actually doing to make me get a picture of what you're doing with a square number?
So a square number. So if I do a square, that makes so 4, 4, 4, 4. Because there's 4 sides and 4 things and 4 edges.
Yeah,
And so 4. So there's 4 4s.
yes.
So 4 times 4 equals 16. So it's basically a bit like the perimeter of the
The shape, okay. Right.
shape.
So Zelig, I love what you just showed on the screen, okay? So do you mean that a square number is that you're multiplying the same digit by itself?
Yeah.
Right, okay, so what is 5 times 5?
25.
So what is 6 times 6?
36.
9 times 9,
81.
12 times 12,
40,
9 times 9,
81.
4 times 4,
16.
8 times 8,
64.
2 times 2.
4.
Right, so what makes all of those calculations square numbers? How do you know they're square numbers?
Because
You're multiplying
multiplying the number by
self, right, okay. Now Zelig, I'm going to push you a bit further. When we talk about numbers and digits, we get a bit confused. So do you mean you multiply the same digit by itself or the same number by itself?
the same number.
The same digit, yeah, okay, because a digit is 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and a number is 10 or more.
Yeah.
Okay, so that's really important that you understand the difference between the two. Right, the bus stop. Who is going to tell me about the bus stop? Is it you, Sam? Right, so Sam, are you? The pen's dropped on the floor, and this is what I mean. No, this is what I mean by live radio. These things have to happen. You know, Sam, brilliant. Have you got your pen? Right, so Sam, should I give you a calculation, or do you want to write your own one?
You can give me
Right, let's have 75 divided by 3. Right. So Sam, can you describe, because don't forget this is on the radio, I know it's on the screen, how have you written that calculation?
So basically 75 divided by 3, so I did a bus stop. Added 33 in the middle, then set 75 in the middle, then put 3 here.
It's 3 on the outside of the bus stop.
And yeah, also the bus stop means divide.
Right, okay. Now Sam, thank you for that, Zelig. Now Sam, some of the listeners might not understand what the bus stop looks like. So I'm now going to ask you to describe, using your own words, what does that bus stop look like?
So basically, the bus stop is just like one vertical line going up,
Yes.
then one horizontal longer horizontal line.
Going which direction? To the left or to the
going
right? Fantastic. So tell me again, without stopping, what does the bus stop look like? It's
So,
one vertical.
It's one vertical line with a horizontal line going right.
Right. Now, so where did you put the 3?
I put the 3 on the outside of the bus
And
stop.
where did you put the 75?
In the inside of the bus stop.
Right, so that's how we start, yeah? So now, can you explain and describe to me, how are you going to solve this question?
So how am I going to solve it? Is how many 3's go into 7? Well, that's 2. So put 2 there. 2 times 6 equals
2 times 3.
2 times 3 equals 6.
Yeah.
So put a 6 here. Then take down the 5. 65. How many?
Oh, hang on. You're doing long division, aren't you? That's long division. Yeah.
So he can do long division and
Yeah.
I can do short.
Okay, hang on. No, Sam. I like what you're doing. So you said how many times can 3 go into 7? It's 2. And what's the remainder? From 6 to 1. So that 1 goes next to the 5. So put the 1 next to the 5 at the top.
No, can I
Yeah. Go on, just put the 1 there, Sam. So you've got 15. Put the 5 there.
So you put a
1
1
there.
there.
That's it. So what number do you have now, Sam? 15. Good. And how many times can 3 divide into 15?
5.
So where are you going to put the answer of 5? So what's the answer then, Sam?
25.
So 75 divided by 3 is 25, and you use the bus stop method. Is that correct?
Yes.
Right. Zelly, do you want to have a calculation?
Yeah, can you make me
Give
one?
Oh, dear me. Look, you put me on the spot already. Right. In the hundreds or the tens?
Thousand.
Let's do
Thousand.
let's do the hundreds. Okay. Right. So let's have 543 divided by 3.
Is this number division?
Sorry, you can have a go as well, Sam.
How many?
What's it?
So the answer is 181.
Can you explain to me how you got the answer, please?
So how much 3's fit in 5 is 1. So I put the 2. So there's 2 reminders. So I put 2 below the 4. So that my numbers 24.
Yeah.
You can put 8 3's in 24.
Yeah.
So I put 8 on the top.
Yeah.
And then there are only 1 3 that can go in 3. So I put 1.
Uh-huh.
So the answer is 181.
And now, Sam, so Zelly, if I asked you to check your answer, would you know how to do 181 multiplied by 3?
Yeah.
Can you show me how to do that, please? Sam, can you do it as well for me? 181 multiplied by 3.
And the method that me and Sam are using is called the written.
Yeah. Well done. So show me how to do it then. Sam, show me how to do it. Put the line underneath the 3. That's it. Well done. So 1 times 3. What's 1 times 3? And then what's 8 times 3?
Oh yeah, I remember.
You got the same answer, 543.
543. So I put the 181 times 3.
Yeah.
So 1 times 3 equals 3. So 3 times you need to put a 0 under the 3 for make it a 10. So 8 times 3 equals 24. So I put 24 next to the 0. And then I put 2 zeros for 100. Then I do 1 times 3 equals 3. So I do 3 plus 240 plus 300 equals 543.
Right, and what you just did there, Zelig, is that you expanded the number. And once again, that is a really good strategy. And I can see you did the same thing as well, Sam. So I can tell the good way that you're being taught by your teachers, because that is exactly what you should be doing. Right, money. Right, Sam, can you please, I've got a question that I want to pose to you two, okay? Now, I've made up this question for today, okay? I'm going to read it out to you, and then I'm going to give each of you a piece of paper that looks like this. Now, here's my question. Listen very carefully. Empty hands, listen very carefully. The bigger the size of the coin, the more you can buy with it. Let me read it out to you again. The bigger the size of the coin, the more you can buy with it. Do you agree? You can write on here, do you agree with me or do you disagree? Okay, Sam, go to the mic. You put false. Why do you disagree with me, please, Sam?
Because 2p is about this big.
Okay. Yeah.
And then if you talk about like 5p, which is bigger than the number 2, it's one of the smallest. So actually, if you look at the money sheet, look, this is 2p. It's below 5p, and 2p is bigger than 5p. So that means it doesn't matter the size of the coin.
So
the value.
Right, exactly. I'll come back to you in a minute, Zelly. Well said. So, Sam, are you saying to me that the 5p coin is smaller than the 2p coin, but you can buy more with the 5p coin than the 2p coin?
Right.
Fantastic. Zelly, what do you want to say?
Also,
Zelly?
also 50p is one of the biggest of the whole thing. So 50p is it has less value than £1, but it's bigger coin. And also 10p is bigger than 20p. You can buy more with 20p than 10p.
I was just going to ask you, how do you know that 50p has got less value or more value than a 20p? Do you go shopping?
Yeah.
So and do you buy your own food? Do you buy your own things when you go to the shop?
Yeah.
You do, okay? And what about you, Sam?
Well, yeah, sometimes, yes.
Okay, fantastic. Right, Zelly, you wanted to tell me about trading.
So in trading, you have a golden goose, and your eggs. So you can't kill your golden goose, which is your total amount. You only use the eggs, which is the amount that you gain by the golden goose. So basically, there's this line that goes up and down.
Very descriptive. Come carry on, I'm enjoying it.
If you go, the lower the line is, the better it is. So
What do you mean?
Buy
what do you mean the better it is?
the better it is because you can buy it and then you wait until it goes up, and when it goes up, you sell it, and then if it goes like up 10%. So if I have 100, 10%, you basically just take out a zero. So if I had 100, if I sell it the line, so imagine it was down here and this was 10%. So 10%. If I had 100 on my golden goose,
yeah.
I would have won £10.
Oh, I see. So 10%. Oh, I get it. I understand. So that's what you remember by trading.
Here you buy.
Right.
Here
you sell, and that's what trading's all about. And Sam, do you know anything about trading? Or
I've heard the word like many times, but I don't really know the mathematical way.
Okay, so Sam, has there been a time where your mum or your dad has said to you that maybe you can sell some of your old toys, or maybe you can make lemonade and sell it? Have they spoken to you about how you can generate and make your own money and be independent? Have they spoken to you about that?
Well, no, not really. I have sold some of my stuff, but that was when I was younger, when I didn't have a bank account, so it went into my mum's.
So have you got a bank account now?
Yes.
You've got your own bank account?
Yes.
Oh my gosh. So you put any money that you get for your birthday present or the tooth fairy and everything can go into your bank account?
Yes.
Right. And does that mean, so you have to make sure that you know how much is in your bank account and no one can touch it apart from you? Have you heard of a debit card and a credit card?
Yes, I've got my own credit card.
You're joking. With your name on it?
Yes. I've got my own debit card that my dad made. It's a Revolut card, and I put some cool stuff on it. Like I put some headphones, and in the middle of the headphones, where there's the place where you put your ears, I put Zelig rules.
Wow.
And I also put wow.
Wow, that's amazing. Right, listen, boys. Unfortunately, we're coming to the end of the math show. Or shall we carry on for another half an hour? No, we can't. No, because someone else is gonna come and do it. But will you come back again?
Yeah. Yes.
Sam, come back again?
Yes.
Now, the next time you come back into the studio, Sam, are you going to interview me? So you're going to sit in this chair?
Yes.
Right, if you're going to sit in this chair, it means you have to be ready with a question for me.
Okay.
Let's have a practice now. What question would you like to ask me? What question do you think could be your first question if you were presenting the math show?
63 times 27.
So you're going to ask me to work out 63 times 27?
Yeah, so I think this week, if I do go on a radio show, I'll be working it out, and I'll and we'll get a piece of paper and write it down.
Right. And is there a question that you would like to ask me, not to do with just with numbers, but is there a question that you'd like to ask me about me? I don't know, anything that comes to your mind. What would you like to find out about me?
When you first started TTRS, what was your studio speed?
Oh, when I first did TTRS, my studio speed is 0.8.
No, when you first started.
Or when I was younger.
Yeah, when you first.
Oh, okay. All right, TTRS wasn't around then, but we had something very similar. And I think when I first started, it was about 1.7 or 1.8, not as fast as you.
Wow.
But you're fast. Yeah, but you're faster. You're faster.
Yeah, I'm 1.05.
That's what I'm saying. That is incredible. That's incredible. That's a very good question. Zelly, what would you like to ask me if we swapped chairs? What would your first question be?
My first question would be, how and when did you first start this radio show?
Right, okay. I started the radio show 2.5 years ago. Yeah. And do you know the reason why I started it?
Can I guess?
Go on then. That's one reason. But someone gave me the reason to start the radio show. Should I tell you why? Let me tell you the reason why. I went to a school. Now, you know about school inspections, don't you? Yeah, you know about inspections at school. And I was talking to an inspector, and the inspector said, "Oh, you can't teach maths on the radio. It's impossible to teach maths on the radio." And I said, "No, you can teach maths on the radio. It's the way that you create that mental picture. Both of you have been doing maths on the radio, and people have been following you. Forget the live stream. They've been able to follow you." Now, because he said that to me, I said, "Right, I'm going to prove him wrong," and that's what I'm doing now. So what I'm telling you both is you can do anything, and if people want to challenge you, let them challenge you, because you are always going to be the winner. So listen, Sam, do you want to say goodbye?
Goodbye.
Have you enjoyed yourself?
A lot.
Zedek, do you want to say goodbye?
Goodbye, and by the way, I solved Sam's question of 63 times 27,
Okay.
which equals 200. Don't tell her. 621.
Okay. All right. Do you know what? I think it might be a little bit more than that. But listen, the fact that you've had a go, that for me is absolutely amazing. So listen.
Can you try to figure it out now?
So use a calculator, or should I do it on the board? Because we're running out of time. So I'm going to do the calculator. Okay. So what?
I said. So 63 times 27.
Okay, right. Okay, 63 times 27. I'm going to do this. Is going to be the last 63 times 27. How do you say that number?
1,701.
That's the correct answer then. Okay, but I know what you did there, and you were very close, so that's not a problem. Okay, can I just say a big thank you to everyone who sent messages, thumbs up, and balloons. Okay. I've had a really, really excellent math show. The table is like a real classroom table. It's messy, but that's because we have been doing maths live on the radio. These two boys have given me so much hope for the future, because as I said, there is no way Sam and Zelig are going to have any problems when it comes to work. People are going to be screaming for Sam and Zelig to work for them, because of what they are doing now. And what Zelig said to me earlier, that when they are both 12 years old, they are going to be steps ahead of me. And I think that's brilliant. Have a great evening. Thank you to Sam and Zelig. Thank you to their mums who sent me a nice message. And thank you to Sam's dad, and his name is Tim, which happens to be my middle name, and happens to be my son's first name. And thank you to Ronnie, who is Zelig's dad. And Ronnie always supports me, and Ronnie is the reason why they are both in the studio. And I'm going to invite them back again very, very shortly, because it's been such an amazing, enjoyable math show. Have a great evening. Thank you very much, and I look forward to seeing you all next week. Bye-bye.